Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC B1239 for the Honda Odyssey models from 2011 to 2017 indicates an issue with the mode control motor circuit. This error can signify either an open or short circuit within the front mode control motor's wiring system. The mode control motor is essential for regulating airflow operations through different vents within the vehicle's climate control system. This component directly affects passenger comfort by directing air from the dashboard, floor, or defrost vents. Its location is typically near the center console, and it operates based on commands received from the climate control unit. Proper functionality ensures that the climate control system responds adequately to the driver's settings. DTC B1239 indicates a malfunction associated with the front mode control motor in the Honda Odyssey. The mode control motor serves the critical function of facilitating the appropriate direction of airflow when drivers or passengers adjust their climate settings. It is located proximal to the center console of the vehicle, interfacing directly with the climate control unit, which sends electrical signals commanding its operation. When an error like B1239 occurs, it typically points to potential wiring issues, such as an open or short circuit. This malfunction can disrupt communication between the climate control unit and the mode control motor, leading to undesirable climate control performance. Thus, pinpointing the exact failure area is crucial in restoring functionality. Several potential causes can lead to the appearance of DTC B1239. One of the primary culprits is an open or short circuit in the wiring associated with the mode control motor. This can happen due to physical damage or wear to the wiring over time. Additionally, a faulty mode control motor can impede the climate control system's operation, causing the DTC to trigger. Another common issue could be loose or poorly connected wires, which may not create a complete circuit, leading to intermittent issues that can be harder to diagnose. These possibilities all stem from either electrical faults or component malfunctions, necessitating a thorough inspection to accurately identify the root cause. Drivers may experience multiple symptoms when dealing with DTC B1239. One notable indicator is inconsistent airflow direction, where the system fails to direct air properly from the selected vents. This can lead to discomfort, as climate control settings may not effectively cool or heat the cabin as intended. Additionally, an error message related to mode control may appear on the vehicle's display, alerting the driver of a malfunction. Failures within the climate control system may also occur, creating further disruptions in managing the vehicle's interior temperature. Recognizing these symptoms quickly can aid in facilitating effective troubleshooting and repairs. The first step in troubleshooting DTC B1239 is to clear any diagnostic trouble codes using the HDS, which stands for Honda Diagnostic System. This tool allows technicians to reset the vehicle's computer, clearing out any stored codes, including B1239. Clearing the codes is essential as it resets the system and allows fresh data to be collected upon reevaluation. After clearing, the ignition switch must be turned to the lock position and then back to the on position. This action restarts the electronic systems in the vehicle, preparing them for the diagnosis of the existing issues. This reset is vital for ensuring that any transient or intermittent fault is accurately documented in subsequent diagnostic steps. Following the clearing of DTCs, the next step involves a simple yet crucial action: turning the ignition switch to the lock position, then back to on second. This process reinitializes the vehicle's electronic systems, including those managing the climate and mode control functionalities. It ensures that any changes made during the previous steps take effect, enabling the vehicle to properly assess the current state of all connected components. This is particularly important because various electronic components require a fresh start to communicate effectively with the vehicle's central computer. This sequential toggle prepares the climate control unit to undergo self-diagnostic functions accurately. In this step, it is essential to perform the self-diagnostic function using either the Honda Diagnostic System, HDS, or directly through the climate control unit. This function systematically evaluates the performance and communication capabilities of the mode control motor and associated circuits. By checking for DTCs again during this self-diagnostic phase, technicians can determine whether the same issues reoccur, thereby isolating persistent faults in the system. The HDS provides digital readouts and valuable codes, allowing a deeper insight into the malfunction while enabling automotive technicians to trace through the components more efficiently. This check is critical for identifying persistent or intermittent failures that might not have been indicated initially. The fourth troubleshooting step focuses on evaluating whether DTC B1239 is still indicated after performing the self-diagnostic function. If the DTC is present, the technician should proceed to the next troubleshooting step to isolate and rectify the issue. Conversely, if the DTC is not indicated, this may signal an intermittent failure, which can frequently result from loose wires or poor connections in the mode control motor circuit. Therefore, further inspection of the wiring and connectors is warranted in such cases to avoid potential future issues. Recognizing and addressing intermittent failure is vital, as it can save time and ensure long-term reliability in the vehicle's climate control functionalities. Once the presence of DTC B1239 is confirmed, the ignition switch should again be turned to the lock position. This action prepares the technician for the subsequent test of the front mode control motor. Proper isolation of the component is fundamental to prevent any unintended electrical surges during testing, ensuring safety as well as accuracy in measurements. Confirming the ignition is off allows for a safe testing environment where connections can be safely accessed and evaluated. This step is foundational before physical checks, as working with electrical components requires utmost care and adherence to safety protocols to prevent any damage to the car or injury to individuals. In this critical step, technicians must test the front mode control motor to determine its operational status. This involves carefully following the manufacturer's specified testing guidelines, which typically include verifying that the motor receives the correct voltage and observing its response when prompted by the climate control unit. If the motor operates correctly, it confirms that the electrical signals are effectively relayed, indicating other issues potentially lie within the wiring. Conversely, if the motor is found to be non-operational, it may require replacement. A faulty mode control motor can prevent the vehicle's climate control system from functioning adequately, leading to persistent discomfort for passengers. The seventh step requires the technician to disconnect the front mode control motor's 7P connector. This action isolates the motor from the wiring and climate control unit circuitry, thus eliminating potential variables that could compromise testing accuracy. Disconnecting this connector provides access to the terminals necessary for continuity checks, which will subsequently help ascertain whether proper connections exist between components. This process is crucial as it ensures all further tests focus on raw electrical pathways, free from the influence of attached components. Safety must be prioritized during this disconnection to avoid damage to the connector and other surrounding components. In this 8th troubleshooting step, the climate control unit's connector A, identified by its 28P terminals, needs to be disconnected. Similar to the prior step with the mode control motor, disconnecting this unit allows for isolated testing of the electrical pathways. This step is pivotal because it ensures that any connections between the climate control unit and the mode control motor can be independently assessed for continuity. Proper procedure includes verifying no remnants of voltage or current in the circuit before disconnection to protect the testing equipment as well as the technician from injury. This careful approach sets the stage for a thorough examination of the connections and wiring that govern the climate control system's operation. The final step involves checking for continuity between specific terminals of the climate control unit connector A and the front mode control motor 7P connector. The terminals listed in the diagnosis should be paired and tested meticulously for continuity, ensuring there are no breaks in the circuit or faulty connections. This procedure determines if the electrical signals can appropriately transfer between the two components, thus validating whether the issue lies within the connectivity or any downstream components. Utilizing a multimeter for testing can give precise readings, indicating if further repairs or replacements are necessary. This thorough examination underlines the importance of electrical integrity in vehicle systems, particularly in ensuring reliable climate control operation. After completing all necessary repairs or replacements, it is crucial to verify that the mode control motor and circuit function correctly. This entails clearing the DTCs again and re-evaluating the vehicle through the self-diagnostic function. Upon running tests, the climate control system should respond appropriately to adjustments made by the driver. Proper functionality signifies a successful repair, while recurring DTCs or symptoms would indicate that further investigation is needed. This verification process reassures both the technician and the vehicle owner that the underlying issue has been addressed comprehensively. Ensuring that all systems operate harmoniously is essential for optimal comfort and performance. To prevent the recurrence of issues associated with DTC B1239, performing regular inspections of the vehicle's wiring, particularly around the mode control motor, is advisable. Protective measures, such as checking for signs of wear, corrosion, or loose connections, can contribute significantly to system longevity. Additionally, utilizing quality components during repairs or replacements can have a notable impact. OEM parts ensure compatibility and reliability. Further, maintaining the climate control system by servicing the air filters and ensuring the system is free of obstructions can enhance performance and reduce strain on electrical components. Developing a routine maintenance schedule will aid in detecting potential issues early, promoting the long-term health of the vehicle's climate control functionalities. In summary, DTC B1239 signifies a malfunction within the mode control motor circuit of the Honda Odyssey from 2011 to 2017. Addressing this error requires a systematic approach to troubleshooting, beginning with clearing DTCs and using the Honda diagnostic system for thorough evaluations. Accurate testing and isolation of components are critical in pinpointing the exact failure sources, whether they originate from the mode control motor itself, the circuitry, or improper connections. To prevent future occurrences of this error, proactive maintenance routines and quality component usage are paramount. Recognizing the significance of these factors ensures long-lasting operation and reliability of the vehicle's climate control systems. Please like and subscribe to the channel. See you next time.